Previously, we talked about electric field and Coulomb's law. Electric field is a region of space where the influence of the electric force is experienced, and the magnitude of electric force that is experienced between two charges can be calculated using Coulomb's law. And what is Coulomb's law? As far as Coulomb's law is concerned, it uh, shows the distance or the magnitude of a force that is experienced between two charges. And it states that the magnitude of the force experienced between charge Q1 and Q2 is directly proportional to the magnitude of the to the product of the magnitude of the two charges and inversely proportional to the square of the distance between them. And mathematically, Coulomb's law is given as F electric force equals to K, which is our constant, multiplied by the magnitude of Q1 multiply magnitude of Q1, Q2 all divided by R squared. That's just as far as Coulomb's law is concerned, and I've explained everything in our last video. But today we are going to talk about the force experienced between two or more point charges. That is, when charges are placed beside each other, what are the types of forces that we can experience and the direction of these forces. And the one major fact is that when dealing with electric force, it is important to know that our force is a vector quantity, which means we are going to take into consideration both the direction and also the magnitude of the force. Between 2 point charges, depending on the nature of the charge, if you have positive charge and also positive charge, that means the kind of force you are going to experience between the two charges will be a repulsive force. But if you have a positive charge and also the negative charge, the kind of force we are going to experience between these two charges will be an attractive force. Now, when dealing with Coulomb's law, it is important to know that force is a vector quantity and it must be treated accordingly. It must be treated accordingly. That is, we need to take into consideration both the magnitude and also the direction of the force. And it is important to know that the force that is experienced between two or more charges is the direction of the force is actually described. It is best described by what? By drawing the diagram. That is, by drawing what? Diagram. Now, if you look at this case, I'm having about 4 diagrams here. This 4 diagram will explain the best way through which you can calculate the magnitude of the force that is experienced between two charges. Now, let's look at our first diagram here. Let's say I'm having charge Q1 that is placed beside what? Charge Q2. Both charges are actually what? Placed in a particular distance between, there is a particular distance between the two what? The two charges. And in this case, what I need to do here is that I need to calculate the what? The total force that is acting on both Q1 and also Q2, you know. And as far as my force that is acting on Q1 is going to experience force due to the presence of what? Of this Q2, right? And Q2 is going to what? To experience force due to the presence of what? Of Q1. But luckily, both of them are going to experience an attractive force because the first one is positive and the second one is what? Is negative. Now, looking at this, the first I'm going to, this charge 1 is going to what? Experience force F1 due to the presence of what? Of 2. Then looking at this, the force F12 is going to move towards what? This direction, because it is an attractive force. It's going to move towards this direction. But looking at this, I'm having what? Force experienced by what? By charge 2, which is what? F2. Q2 experience what? That is our charge 2 experience force due to the presence of what? Of 1. That means I'm having what? F21. But if you look at the direction of what? Of this is coming what? Down this way, because it is what? An attractive. Both of them are going to what? To move inward with each other. Now, looking at this, I'm having my F12 here and also my F21. Now, if I want to specify the direction of the force, this one is moving in what? In positive side. I'm going to have my F12, right, to be equal. Looking at this one move towards what? Negative side. That means I'm going to have F12 equal what? Negative what? F21. That's just it. Can you see this now? That means for a charge, for the force experience between two charges that are placed beside each other, is actually F equals to what? Minus F. The force experienced by the first charges equals to what? Negative of the what? Of the force experienced by what? By the second charges. Looking at this, and it depends on the position of the charge of the two charges. Now, let's say this is what? Our Q1. Our Q1 is placed there, and our Q2 is what? Is placed there. That means we'll be having our F21 to be negative, and F21 to be what? Negative what? F12. If, let's assume I interchange them. That's just it for the first case. Now, looking at the second case, I'm having charge Q1, Q2, and Q3. And I'm very sure that a force is going to be experienced between these two charges, right? So looking at this, my Q1 is going to experience a repulsive force due to the presence of Q2. My Q2 is going to be attracted to what? To Q3. But luckily, here in this case, I'm only after what? The two forces that is acting on what? On Q3. Two forces acting on what? On Q3. Because Q3 is the only what? Negative charge between the what? Between apart from this positive charge. So this positive charge are going to what? To experience a repulsive force. Why this will also what? Experience what? An attractive what? Force. This charge Q2 is going to what? To get attracted to what? To my Q3. That means the force I'm going to experience is what? Is F2 3. And it's going to move towards what? Positive side. And this charge Q1 is going to what? To experience two type of force. The first one is what? Is that force that is coming from what? From this charge Q3, which is what? Attractive force. And the second one is what? Is the force coming from what? From this charge Q2, which is what? A repulsive force. You understand it now? So in this case now, this will try to what? To repel this and what? And move towards this side. She gets right now. But due to the presence of what? Of this Q3, the repulsive force is going to be what? Is going to be towards positive side. That means both repulsive force that is both forces, the repulsive or the attractive that is experienced towards Q1 and Q2 and also Q2 and Q3 will be positive because both forces move in what? In positive direction. Looking at this, my Q1 will repel this. Actually, it's supposed to move towards what? This side, but due to the presence of what? Of this Q3, it's going to be attracted towards what? The positive side. So that I'm going to have what? My F1 2. That is the force of repulsive force that is experienced between 1 and 2, which is F1 2, will be equal to what? That's what? F1 3. Because everything moves towards what? Towards this side. Both the repulsive force acting on this Q1 and also the attractive force acting on this what? This Q1 move towards what? The positive side. That's why I'm having this to be what? To be equal. Considering the direction of both forces is actually what? Is actually positive. Now looking at the next one I'm having here, I'm having my Q1, Q2, Q3. Now in this case, I just need to consider some things here. Looking at this, I have my Q2 here, my Q3 here. Between this Q2 and Q3, there is actually a force that is going to be experienced between them, but the force is what? Is an attractive force. Considering my Q3 as my main what? Main point charges, this Q2 is going to be attracted to Q3 towards what? The positive side. Can you see this now? But considering Q1 and Q3, the repulsive is going to be towards this side. The repulsive force is going to be towards this side, right? And my attractive force is going to be within each other here. She gets right down. But looking at this is an hypotenuse line. This force, this attractive force, we can specify that F32 is an attractive force, and also it is an horizontal force because the force acts on horizontal line. If you look at this very well, that means I don't have to resolve this into any component. I don't have to resolve the force F32 into its component because I can specify and I can confirm that it moves towards what? The horizontal. The force acts horizontally. Now looking at this, my FQ3, which is what? The F31, the force that is experiencing what? Charge Q1 and Q2. It is an horizontal line, which is what? It is an hypotenuse line rather. And this hypotenuse line, I'm not specifying maybe it is what? It is I'm not sure maybe it is what? If it is vertical forces or what? Or horizontal forces. That's the reason why that anything I have, if I have any hypotenuse line, that means I will have to resolve into its components. Resolving this into its components, I'm going to resolve it to my F31x, which is what? The horizontal, and also what? F31y, which is what? The vertical. The formula for F31x, just as I'm considering what? The angle, that was what? F31x equals what? The force F31 itself cos what? Cos theta, as far as horizontal is concerned. But as far as vertical is concerned, I'm going to have my F31y to be equal F31 sine theta. That's just it. So in this case, I will resolve into its components, and I will have to calculate the horizontal force acting on what? On Q3. I'm having two forces acting on Q3. The first one is what? Is the attractive force, and the second one is what? Is the repulsive force. The repulsive force is what I just need to resolve into its component because it provides an hypotenuse line here. You get straight now. Now looking at the fourth diagram I'm having here. The fourth diagram, looking at 0, I'm having Q1, Q2, and Q3. But luckily, all charges are positive, which indicates that whenever I want to calculate, if I want to calculate any force, any resultant force on Q3, everything is going to be what? A repulsive force. Q2 is going to what? This is going to what? To move this side. That is the first experiment between what? Q2 and Q3 is going to move towards what? Towards this side. The first experience what? Between Q3 and Q1, which is what? Is going to repel towards this side, and it is what? That's my F31. Right? So in this case, I have horizontal force acting on Q3. In this case, I have what? Horizontal force acting on Q3, but it's moved what? Inward. It is an attractive force. But here, I have horizontal force acting on what? On Q3, which is what? A repulsive force. But here, I can identify about my hypotenuse line. Identifying this hypotenuse line indicates that I will have to what? To resolve this, my line into what? Into components again. Similar to what? To this. But the only difference is that this one experiences what? All repulsive force. All the force experienced here is actually repulsive. While here we have both repulsive and also attractive force. Now looking at this now, this is going to move towards this side. This is an horizontal. I can specify that this my force that move towards this side is what? Is horizontal, right? But here I can't verify it yet. I can't verify that okay, this is what? Horizontal or what? Or vertical. Then I will have to resolve the force that move along this side into its components, which is similar to this. That means I have to calculate in such a way that I have my F31 cos what? Cos theta, which is equal to what? My F31x. F31x exactly. Then here I'm going to have my F31 sin what? Sin theta, which is equal to what? My F31y. That's just resolving to its components. Then after that, I will have to calculate what? The net horizontal force acting on what? On Q3. The net vertical force acting on what? On Q3. The net horizontal force acting on what? On Q3. I will have to calculate it on both sides, but I'm assuring you guys that I'm going to solve different questions on it so that you have a better understanding. Now let's just check the question I'm having here with me. I'm having just 2 questions here. You can just pause the video and try it. So just try to attempt the question and let's see if you are going to get the answer. So looking at the first case I'm having here with me, the question says that 3 charges lie along x-axis. The positive charge Q1 equals to 10 microcoulomb and is at x equals to 1 meter, and negative charge Q2, which is equals to minus 2.0 microcoulomb, right, is at the origin. Where must a positive charge Q2 be placed on the x-axis so that the resultant force on Q3 will be 0? The question is actually straightforward because the first thing we have to do is just what? To identify our Q1 and Q2 and Q3. Okay, my Q1 is at what? At x equals what? 1 centimeter. That means from this point, which is what? Origin, to this side, which is what? Let's just say this side, that's 1 centimeter. I'm having my Q1 here, which is what? That's 10 microcoulomb, and it is positive. It's a positive charge. Then looking at this side, I'm having what? I'm having 3 charges lie along. I'm having my what? Okay, and negative charge Q2 is at origin. Is at the, that means my negative charge should go to be placed here. I'm having negative charge here, which is what? My Q2, and that's equals to negative 2.0 microcoulomb. Now the question asks, where must the positive charge Q2 be placed on the x-axis so that the resultant force on the Q3 will be 0? Looking at the second diagram I'm having here, I place my Q2 here. That means the force of attractive force, the attractive force here is actually what? The force is attracted to this side. The force is also what? Repulsive to this side. That means my attractive force, my total attractive force is equal to what? Total repulsive force. So you understand it now? Now looking at this now, in order for me to just to look for a way to place my Q3, I would rather place it what? At the middle, because placing it at the middle, it's actually a positive charge. This will get attracted to this, and this will repel towards the side. The repulsive and also the attractive force will be towards the side. You understand it now? It will be towards the side. That means I'm having what? My Q3 here. So now here from this point origin to this point, I'm having my x to be equal to what? That's 1 meter. So now I just need to go ahead and calculate the force experienced between Q2 and Q3. That means my F3 is going to experience force due to presence of 2, which is what? An attractive force. I'm having it there. And the distance between Q2 and Q3 will be what? X. Because if we have from this side to this side to be 1 meter, that means from this side to this side will be what? Will be an unknown value. Then I'm having it to be x. Then the distance between this side to this side will be equal to what? That's 1 minus x. If this is x, I know that the distance between this this origin to 1 meter is 1. That means subtracting x from this one, I'm going to have the remaining distance of this, which is 1 minus x. So now, another thing we just need to consider here is that the force acting between Q3 and also Q1 is actually what? That's F31, and it's what? A repulsive force. You understand it now? So in this case now, I will have it in such a way that my F32 must be equal to what? That's F31, so that what I will experience the net source of what? Of 0 on charge what? On charge Q3. Now looking at this, it's a very simple thing. I'll just say, okay, my F32 is equal to what? To F31, right? So in this case, I'm having what? 2 multiplied by 10 is power what? Minus 6, because this is micro Coulomb. So equals to what? All divided by what was my that's actually my r. My r is what? Is s squared. The reason I'm having this is that, if you recall Coulomb's law, right? I'm having it what? F equals to what? That's kq1, right? q2 over what? Over r squared. Then let's just say this is what? My f32. Then my f31 now will be equal to what? Kq1, right? This one should be q2, q3. Kq1, then q3 over what? Over r squared, right? If I should equate them, I'm going to have it such that I'm going to have kq2 q3 over what? R squared equals to what? That's what? kq1 q3 over what? Over r squared. Equating them, then this will cancel out this. I'm good. Then q2, I'm going to have q1, q3 will cancel what? q3. Then I'm having what? q2 over r squared divided by what? q1. That's q1 over what? Over r squared. That means I'm having what? 2 multiplied by what? 10 is power what? Minus 6 divided by what? R squared. Exactly, which is what? My s squared equals to what? That's the next one is what? That's 10. 10 multiplied by 10 is power what? Minus 6 divided by what? R squared, which is what? My 1 minus what? X all squared. So in this case, this will cancel out this. I'm going to have 10s squared, right? Equals what? 2 into brackets 1 minus x into brackets 1 minus x. Just need to open the bracket. I'm going to have 10s squared to be equals to what? That's 2 into bracket, that's 1 minus 2x, right? Plus s squared. So here I'm going to simplify. I'm going to have 10s squared to be equal to what? That's 2 minus 4x plus what? 2s squared. So in this case, just need to collect lifetime. Collecting lifetime, I'm going to have 10s squared minus what? 2s squared, right? Plus 4x minus 2 equals what? 0. So here I'm going to have it to be 8s squared plus what? 4x minus 2 equals what? 0. So here I just need to divide both sides by what? By 2. Dividing both sides by 2, I'm going to have, dividing all through rather by 2, I'm going to have 4x squared, right? Plus what? 2x, then minus 1 equals what? 0. So looking at this, this is just simple quadratic equation, right? I will need to recall my quadratic formula, which is what? S equals what? Minus b, then plus or minus root of what? Of b squared minus what? 4ac all divided by what? 2a. Then in this case, my what? My a will be equals to 4, my b will be equals to what? 2. Then I'll have my c to be equals to what? Minus 1. So you just need to what? To put it here. Wherever you see b, put the b there. Wherever I see a, put a there, and also what? Your c, put it there. So without wasting our time, the value of x is actually what? That's the first one is what? 0.31, and also what? Our x equals what? Minus 0.809. That means the distance I need to place my Q3 so that the resultant force on Q3 will be equals to what? Will be equals to 0. Should be something like that. Should be either 0.31 to the positive side or minus 0.809 to the what? To the negative side. So here I'm having what? Negative answer here. I'm going to approximate to what? Negative 0.81, which is what? Which is A. That means I need to place my charge towards what? Towards the negative side. That's negative 0.81 in order for me to experience zero net force. Now let's move to the second question here. You can actually try the second question, and let's see if you are lucky enough to get the answer. Make sure you drop your answer in the comment box below. Now let's just move to the second question. The second question I'm having here says that's if point charges Q1 equals what? 10 microcoulomb, right? I'm having my Q1 to be equals to what? That's 10 microcoulomb, right? Then my Q2 to be equals to what? That's negative 5 microcoulomb. As separated by a distance, the distance between them, that's R equals to what? 100 centimeter, which is also approximate to what? To approximately, even that's multiplied by 10 to the power minus 2, which is what? That's 1 meter. Then where must a third charge be located so that it will experience zero net force? It's still the same thing as the first one that we calculate. So we just need to just go ahead. My Q1 is at what position? My Q2 is at what position? Both Q1 and Q2, they are at what? At 1 meter to each other. That means I'm going to have it to be something like this. I'm going to have my Q1 to be here, and my Q1 is positive, right? Also, I'm having my Q2 to be here, right? So which is what? Negative. But it is advisable to place Q2 at this side because it is a negative charge. To place at what? At negative side. Placing it at negative side, I'm going to have it what to be, that's my Q2 to be here, right? And my Q1 to be here, which is what? Positive. But both are what? Are distance. They are 1 meter distance. They have 1 meter distance between them. So now look at this now. Where must the third charge be located so that it will experience zero net force? So am I going to place it at the middle, or I'm going to place it toward the side, or I'm going to place it toward the side? Now placing it at the middle will be the best thing to do, because if I place it toward the side, the attractive force will move toward the side, and also the positive force will move toward the side. That means both are moving in what? In the negative side. That means in order for me to experience zero net force, it's not possible for me to experience it, because since both are moving towards the negative side, it's not possible. But if I place my Q3 at the middle side, there will be a repulsive force here, and there will be an attractive force here. The repulsive force will be equal to the attractive force. That means my F3 is going to experience force due to the presence of what? Of 2, and my F3 is going to experience force due to the presence of what? Of Q1 here. She get right now. So the distance between them is still what? 1 minus x. Then we assume this one to be x, an unknown value. You understand it now? So in this case, let's go and record the Coulomb's law. It's still the same thing as we did here. So here we're going to have my F32, right? F32 to be equal to what? That's F31, right? So we just need to follow the normal procedure and we'll be good. So in this case now, what do you think we can just do? It's still blah blah blah, the same thing. So try to attempt it. Let me just try and complete this for you guys. So I'm going to have 5 multiplied by 10 to the power what? Minus 6, which is my what? KQ3 Q2 divided by R square equals what? Q3, right? Q1 over what? R square. So here I'm going to have these two to cancel out. I'm going to have Q2 over R square. What's my Q2? My Q2 is 5. That's why I put 5 here. Divided by R square, the distance between this, that's S square, right? Equal. You are going to have your F31, which is what? Q1. You're having Q1 left. Q1 is what? That's 10 microcoulomb. 10 times 10 is power minus 6, right? Divided by the R square, which is 1 minus what? X. So here in this case, my this you cancel this, right? I'm going to have 10s squared equals to what? 5 into brackets what? 1 minus x. Just open the bracket directly. So you are going to have 10s squared to be equal. That's 5 into brackets 1 minus 2x, right? Then plus what? S squared. So you're going to have this to be this. That's just 10s squared equals to what? 5 minus 10x, right? Then plus what? 5s squared. So in this case, you're going to have 10s squared minus what? 5s squared, right? Then plus 10x minus 5 equals to 0. So here I'm going to have 5s squared, right? Then 5s squared plus what? That's 10x, then minus 5 equals to what? 0. So I can still choose what? To divide all through by what? By 5. Dividing all through by 5, what am I going to have? I'm going to have, I should be having, okay, exactly, this is 5s squared, exactly. I'm going to have s squared, right? Plus what? 2x, exactly. Then minus 1 equals to what? 0. So here I can just choose what? To use quadratic formula or try to factorize. So using quadratic formula, you're going to have what? You're going to record formula s equals to what? Minus b plus or minus root of what? B squared minus 4ac all divided by what? 2a. So in this case, you have it to be what? You have it to be your a equals to 1, your b equals to 2, your c equals to what? Negative 1. So try to put in the formula. You get the value of x. First x to be equals to what? That's minus 2.414, and your S2 to be equals to what? That's 0.414. That's just it. So you have your first x to be negative 2.214, and your second x, that's x1 and x2, to be equal 0.414. Now look at this now. The answer here, that your option here that I have here, is actually negative 2.414. That means we need to place our third charge at the negative side in order for us to experience what? The net, in order for the force acting on the Q3 to be 0, we need to place our charge, our Q3, towards what? Towards the negative side. So here I'm going to pick option what? Option B. So if you get a different answer for this, kindly drop it in the comment box below. And don't forget to click on the subscription button, and feel free to DM me if you have any problem, you have any question to solve. Yeah. And our next video will actually be on let me just say it will be based on these two diagrams. I'm going to try to solve some question on these two diagrams so that you have full understanding on electric field, and also the force that is experienced between two charges. So alright guys, thanks for watching.